You know, there's this incredible thing that happens in pretty much every home all around the world. It's one of the greatest mysteries of human development, but it's so common we almost take it for granted. I'm talking about a child's first words. So today, let's dive into this spectacular puzzle.
So here's the big question, right? How does that random babble, all the coos and gurgles, somehow transform into actual, structured, meaningful language? How do kids manage to master this ridiculously complicated system of sounds and meanings, usually in just a few years and with no formal lessons? Well, that's the puzzle we're going to try and piece together today.
And here's our roadmap. We're going to start by looking at this whole thing as an everyday miracle. Then, we'll frame it as something called the discovery problem. After that, we'll peek under the hood at the brain's secret program, see how a world of words gets built, and finally, we'll push the boundaries and ask, what lies beyond words?
All right, first things first, we really have to appreciate what an absolute miracle this process is. We're talking about one of the most complex cognitive skills any of us will ever learn in our entire lives, and we do it before we can even tie our own shoes. It's wild when you think about it.
The official name for this is first language acquisition, and the definition here is so important. It's not just about memorizing words. It's about mastering a system for connecting sounds with meanings. And here's the kicker. It all happens with just casual exposure. Nobody's sitting a 2-year-old down with grammar flashcards. It just happens.
Okay, so if it all happens so naturally, how in the world do you even begin to study it? Well, researchers frame it as the child's discovery problem, and they look at it from two really interesting connected points of view.
So on one hand, you've got the child's problem. Their job, even though they don't know it, is to build a complete working grammar from scratch. Then on the other hand, you have the linguist's problem. Their job is to figure out how on earth the child solves their problem. It's like a puzzle wrapped inside another puzzle.
To crack that double puzzle, we have to look inside. We have to investigate the brain's secret program. I mean, if a kid isn't being explicitly taught, there has to be some kind of powerful internal machinery doing all the heavy lifting. So what's going on in there?
Well, scientists call this the mental mechanism, and the best way to think about it is like a piece of pre-installed software. It's a program that's hardwired right into a child's nervous system, and its main function is to listen to all the messy, chaotic language happening around them and somehow build a stable, accurate model of how it all works.
So how does this program run? It basically follows 4 key steps. First, it just soaks up all the raw sounds. Then, like a little detective, it starts to spot patterns, recurring sounds, rhythms, sentence structures. From all those patterns, it starts to build a grammar, all unconsciously. And then, the final magical step, it connects all of that structure to actual real-world meaning. The sound bottle is no longer just a sound, it becomes that thing you drink from.
Now, once that internal program is up and running, an incredible transformation starts to happen. We go from the brain's physical hardware to the mind's abstract software. The child literally starts to build an entire world out of words. And this creates such a profound shift. You see, language isn't just a bunch of labels we stick onto a world we already know. As this quote suggests, language actually becomes the framework we use to understand reality. The world, for us, is rebuilt piece by piece through language.
This happens because we create something called mental models. As a kid picks up language, they're also building an internal blueprint of reality. The words in the grammar become the scaffolding that supports their understanding of everything. It's what lets them navigate and interact with the world in more and more complex ways.
And these words aren't just stored in neat little files, oh no. They form these vast, sprawling, semantic networks. You can picture it like a giant, growing spider web in your mind. Every single word is a point on that web, and it's connected to tons of other words. Dog connects to bark and fur and pet and maybe walk and loyal. And these networks are absolute powerhouses. They don't just hold words. They are the engine that lets us understand really complex ideas. They help us learn new vocabulary by linking it to what we already know, and they allow us to find the perfect word in a split second without even thinking about it. This mental web is really what makes language so flexible and powerful.
So, all of this leads us to our final, and frankly, kind of mind-bending section, beyond words. This is where we get to explore the really deep and maybe even limiting consequences of this incredible system we've built in our heads.
Here's a wild thought for you. As amazing as language is, it might not be perfect. There are actually some mathematical models that suggest a startling possibility, that there are inexpressible thoughts,
ideas that our minds might be able to form, but that our language just doesn't have the structure to capture or communicate. It's like the tool isn't quite big enough for the job.
And that leaves us with one last massive provocative question to think about. If the language we learn as a child literally builds the framework for our consciousness, if it shapes how we see the world and what we can reason about, well, what thoughts are we unable to think? What ideas are sitting just outside the limits of the words we know?